important constituent of hemoglobin, which is in blood. Iron is the metal used most widely in industries and hence may be called the king of metals. It is the second most abundant metal after aluminium. Iron does not occur in native state since it is oxidized easily. Iron is usually extracted from hematite and limonite. The extraction of iron from its ores involves three steps: concentration, calcination, and reduction. Hematite is concentrated by hydraulic washing or gravity separation, while magnetite is concentrated by magnetic separation. The concentrated ore is then subjected to calcination. Calcination is the process of heating the ore to a high temperatures in the absence of air to remove impurities such as moisture, sulfur, arsenic, and carbon dioxide. At this stage, the ore becomes porous. The calcined ore is then smelted. Smelting is a process of reducing an oxide with carbon in the presence of flux of a high temperature. Smelting is carried out in a blast furnace. A blast of hot air is blown into the furnace through water-cooled nozzles. The charge, which is calcined ore mixed with limestone and coke, is fed into the blast furnace. The ore gets reduced by coke to metallic iron, which deposits at the bottom. In the furnace, carbon dioxide is produced at the bottom due to the combustion of coke. As carbon dioxide rises upwards, it is reduced to carbon monoxide accompanied by heat absorption. Limestone, which is sliding downwards, decomposes to give lime and carbon dioxide. The lime thus obtained acts as flux and combines with silica to form calcium silicate. In the upper part of the furnace, iron oxide is reduced to spongy iron by carbon monoxide. At the bottom of the furnace, the molten iron sinks, and above it floats the fusible slag, which protects the molten iron from oxidation. The molten iron and slag are collected separately through different outlets at the bottom. The molten iron withdrawn from the furnace is called as pig iron. It is either converted into wrought iron or steel or is cast into molds. Iron is a greyish white solid metal. Pure iron is soft and malleable. Iron is a good conductor of heat and electricity. The melting point of iron is 1538 degrees Celsius and liquid iron boils at 2862 degrees Celsius. Some of the chemical properties are its reaction with air. When left in open moist air, iron reacts with oxygen and moisture to form rust or hydrated oxide of iron. On heating in air, it burns and gives sparks to form oxide. Reaction with steam. When steam is passed over hot iron, hydrogen is liberated along with iron oxide. Reaction with some acids. Iron reacts with dilute hydrochloric and dilute sulfuric acid to produce ferrous chloride, hydrogen, and iron sulfate. On heating, iron reacts with non-metals like sulfur and chlorine. Iron is more reactive than some other metals like nickel, platinum, copper, and silver. Thus, it can displace these metals from their salts. Iron is useful in the manufacture of automobiles, machinery tools. It is very much useful in various constructions. It is used as a catalyst in various enzymatic reactions. Metallic iron is useful in the making of electromagnets.